Continuing to analyze graphs of trigonometric functions, we're now going to be talking about translation of trigonometric functions, and we start off with a phase shift. And a phase shift is, as we have seen in other functions, the transformation of other functions. This relates to a horizontal shift along the x-axis is a good way to think about that. Now, we've already looked at, and we're dealing with a cosine function here, so we'll stick with it, where we've got a cosine b of theta, let's say. Sorry, theta. Where a relates to the amplitude, and B relates to the period. Now, B doesn't define the period, but it does relate to it. Now, when we're dealing with, just as a review, when we're dealing with sine and cosine functions, our period is 360 over the absolute value of B. And if it's a tangent or a cotangent function, it's 180 over the absolute value of B. So B helps to determine the period, and now we introduce something else, which is H. And H relates to the phase shift or the horizontal shift. So let's work with our problem here. It says that state the amplitude, period, and phase shift for y equals 2 times the cosine, in parentheses, theta plus 45 degrees. And then we'll graph the function here in a minute. So the amplitude, well, in this case, it's going to be 2. And the period, which is a cosine function, so we would start with 360 over the absolute value of B, but B in this case is 1. So this period then would be 360 degrees. And the phase shift, now you have to be careful here in that if you look at this, this is negative H. So if I've got a positive 45, think about it as this. Let's say 2 times the cosine of theta minus, and it would have to be negative 45 for that to be a positive. So our phase shift then is negative 45 degrees, which means that it's going to shift the graph to the left on the horizontal axis by 45 degrees. So there's a couple of ways to look at it. One, you can look at it like I did right here, or just kind of think a little bit counterintuitive. Ordinarily, when we think about positive numbers on the x-axis, we want to go to the right. Negative numbers are going to go to the left. But if it's a minus h like that is, it's really going to take that what I see as a positive and move it to the left, not to the right. So I moved it to the left, negative 45 degrees. Now we're going to go graph the function on the calculator and take a look at what we see. All right, so I'm over here on the calculator, and first thing I need to do anytime I'm looking at trig functions, I want to double check, do I need to be in radian or degree mode, and make a change if necessary. Now in this function equation we were given, it was given to us where we had 45 degrees on that phase shift, so we know we need to be in degree mode, and you can see I'm already there. And then I want to go to the window setting and think about, okay, what do I really want to do? So I know that the amplitude is 2. Now, ordinarily, a cosine function is going to fluctuate between a peak at 1 and a trough at -1, and that's going to double. And so you can see here I set my y minimum to -3 and my y maximum to 3. That's to at least cover the 2. I could put -2 and 2 would be fine too, because I want to be able to see the apex and the trough of the sine curve, of the sinusoidal curve. And then on my x minimum and my x maximum, so I know I've got a period of 360. So one full cycle is going to take 360 degrees in this particular equation. And we had a phase shift of 45 going to the left. And so I set my x minimum at -90 just to make sure I actually get to see that phase shift going -90. And then I went 180 degrees beyond the period of 360, so I set my x maximum at 540, and then you can see I set my x scale at 45 degrees. So every little tick mark along the x-axis is going to represent 45 degrees. Now, I'd already entered the basic cosine functions. Let's just go take a look at that. And you can see that we got a peak here at 1, we got a trough down here at -1, and we've got one full cycle going from right here on the where x is equal to 0 and y is equal to 1, all the way over to this point where x is equal to, let's see, 1, 2, 3, 4, 5, 6, 7, 8. And that's 8 times 45. That should be 360. Hopefully it is. $360 degrees. So my period looks correct. Okay, now let's go graph the transformation where our amplitude changes from 2 to 1, or from 1 to 2, I should say. And then we got cosine, and I don't have any b value here, so the period is going to remain 360. We'll substitute x for theta, and then plus 45 degrees. And close my parentheses here, and let's go look at our graph. It's going to show up in red. Now, I can see here from amplitude, look, it goes up to, right here is at positive, where y is +2, and down here at the trough, y is -2. That represents an amplitude change from 1 to 2. And we measure that from the midline. And on this particular function, the midline is the x-axis. So in the blue, it goes up 1, it goes down 1. And the amplitude is the measure of change from the midline to either the top of the curve or the bottom of the curve. But in our red, in our transformation, we got 2, so notice it goes up from, and midline is still the x-axis, goes up 2, goes down 2. And then if I look here, each tick mark is 45 degrees, and so you think about, at this point that's on the y-axis, shifting 45 degrees to the left. And sometimes these phase changes, at least for me, I have to really think about those because it's a little bit hard for me to see the shift, particularly when I got an amplitude change. I mean, because it jumps it up and jumps it down further. Now, what about my period here? So we're going from -45 to 1, 2, 3, 4, 5, 6, 7 on the positive. So 7 times 45. What's 7 times 45? 315 plus the 45 that went on the negative side is 360. So my period all looks good. And that's the graph showing the translation with the phase shift. Shazam.